The last step in factoring is called factoring by grouping. And this is what we use when you have four terms that you need to factor. And the steps are, we're going to first look for a greatest common factor common to all four terms. Secondly, we're going to look for three terms that make a special formula. Or we're going to look for two terms that make a special formula. And then last, we're going to group each of the four terms into two groups of two to see which ones have a greatest common factor. And then when we factor, each group needs to have another greatest common factor in this particular situation. So let's look at an example and first check to see if there's any greatest common factor common to all four terms. Not the case. See if any three of them make a special formula. Not the case. No two of them make any special formula. So we're going to have to group them two by two and see which ones have a greatest common factor. This first, third, and third term both have a greatest common factor. And it looks like also the second and the fourth term will have a greatest common factor as well. So let's regroup them and rewrite it using the associative property. Yep, that's the associative property. And let's write it as 3xy minus 6x, put parentheses around it, plus 2y minus 4. Let's find the greatest common factor in each of these two binomials. So in the first one, it's 3x is the greatest common factor. 3xy divided by 3x leaves us with y. Negative 6x divided by 3x leaves us with minus 2. And the second group, the second binomial, 2 is the greatest common factor. So 2y divided by 2 is just y. Minus 4 divided by 2 is minus 2. And as we look, the parentheses themselves are a greatest common factor. The y minus 2 is common to both of these terms. So what we're going to do is factor out this y minus 2, and what's left is going to be our other binomial. So let's look at that. Since y minus 2 is the greatest common factor, 3x times the binomial y minus 2 divided by y minus 2 leaves me with the 3x. And then plus 2 times y minus 2. When we divide that by y minus 2, that leaves me plus 2. And so factoring by grouping takes those four terms, and we get to factor it down as a product of binomials. And if you're not sure, you can FOIL your answer back out to check to see that that's our original polynomial. Let's look at another example. S squared minus 4t squared minus 4s plus 4. First, is any greatest common factor common to all four of them? No. Then, do any three make a special formula? That is the case. So all we want to do is to rewrite it, because s squared minus 4s plus 4 makes a special formula. And in that case, we're going to use the associative property to put parentheses around s squared minus 4s plus 4. What special formula is that? That's the perfect square trinomial formula. And this minus 4t, we're just going to write behind for now as minus 4t. So again, perfect square trinomial. First, it's a trinomial. Second, last term is positive. Third, first term is a perfect square. The fourth, the last term is a perfect square. And when we take their two square roots, s and 2, multiply them to get 2s, double it does give us 4s. So that factors as the square root of the first one, square root of the last one, sine of the middle one. Now what we have here is parentheses squared minus 4t squared. We're not done. This is a perfect square minus a perfect square. It's as if, and just think for a moment, instead of the parentheses, think of p representing the parentheses. It's like p squared minus 4t squared. That's the difference of two perfect squares. And so is this, the parentheses squared minus 4t squared. So yep, we have the difference of two perfect squares. And we're going to factor that as the square root of the first one times the square root of the second one. And then our signs are going to be one of each. So we have conjugates. Now I'm going to leave the parentheses around the s minus 2, but we don't need parentheses in brackets. So it's s minus 2 minus 2t times s minus 2 plus 2t. So we have two trinomials actually. And to check that out, we'd have to think of triple the distributive property. S gets multiplied by everything, the negative 2 gets multiplied by everything, the negative 2t gets multiplied by everything. Alright, and that's our look at factoring by grouping, and this wraps up factoring for us. So we'll start some homework on that.